y'all probably have seen this before. I feel like y'all are 100 feet away from me because everybody is scooted back. I'm just like, okay. So really, I want to go over this because you may see this. There is a factorial button on your calculator. It's not that if they do 5 factorial, they're not screaming 5 at you. So basically on page 117, if you'll look at the definition of a factorial at the very bottom of page 117, 0 factorial is defined as 1. If you do that on your calculator, you will get the answer as 1. But what it is for, if you have r factorial and r is greater than or equal to 1, can't be 0, then the factorial is the product from 1 to r. So in other words, when you have 5 factorial, that is 1 times 2 times 3 times 4 times 5. A lot of the times it's written backwards, 5 times 4 times 3 times 2 times 1. That's the way I've always written it. But I like to write it the way that it's written as the definition from 1 to r. Okay, so that's just really that. Nothing hard or difficult about that. It plays into what we're going to talk about next, not so much directly, because of we're going to do most everything on our calculator and we're going to use combination. But we're going to get into Pascal's triangle or binomial expansion. Pascal's triangle. And this will begin on page 128. So basically, this is for binomials, not for 3 terms, not for 4 terms, but only for 2. So if you had x plus 3, and we wanted to square that, okay, we would basically just FOIL it. We would use the FOIL method on that, correct? Simple enough. But what happens if we have something like this to the 6th power? Okay, you really do not want to FOIL these out. You do not want to do this. Don't want to do that. You want to use what we call as binomial theorem or expansion. Makes life much easier, less room for error. So you had this in IGSI too. I know you did because I know you were tested, or at least it's typically on the test. Okay, so let's talk about the binomial expansion. You have 2 terms here. Now what I typically do is this is to the 6th power. You're going to have 1 more term than you have power. So if I have to the 4th power, I would have 5 terms. That means the first term is the 0th term. So what you do every time is you put, if there's more than one thing here, if that's 2x or 3x or 3xy, it doesn't matter what that is. If it's more than just one component, you put it in parentheses. So we're going to say 2x gets all the power, okay? The 3 gets none of it. So the first term, okay, the first term in the binomial expansion gets the whole power. Now, let me put this down. Oh, okay, there we go. I'll let y'all have a minute. I know some of y'all have been done with your quiz, but I'll let you have a minute. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, okay. So I went back and added this because I meant to tell you this already. In binomial expansion, there are really two key components. And if you can remember these components, you won't miss anything. First of all, we need to expand the terms here. That's what I'm getting ready to do. Okay, so I'm going to write this in red, and I'm going to tell you step 1, expand terms. Okay. The second key component, not the second step necessarily, but the second key component is Pascal's number. Okay, we're going to talk about both of those. But right now, let's go back and we're expanding these terms. So 2x gets all of the power, 3 gets none of it. Now, I'm going to put a plus here because this is a plus. We'll talk about minuses tomorrow. Okay, that does change things. So then the first term goes down by 1 power, and the second term goes up. This should still add to 6, or whatever this is up here. Okay, so then 2x goes down to 4, and 3 goes up to 2. I'm still adding to 6. That's called the degree. All right. 2x goes to 3. 3 goes to 3. Then the 2x goes down to 2. The 3 goes up to 4. If you're watching to see if they stay the same degree, you won't make a mistake. The 2x goes down to 1. The 3 goes to 5. And then the 2x goes down to 0. The 3 gets all 6. So let me stop right there and see if there are any questions. Y'all remember doing this at all? Y'all did not do this? I know I taught it, and I thought easy too. Okay, so now the second thing that we're going to do, the second step, step 2, this is not the second component, but this is step 2. Simplify. You're going to take your calculators out. Now, this is going to be real easy if you'll just follow along with me. Now, if you did not put your parentheses here, you're going to miss it. Okay? Because it's not 2x to the 6th, it's 2x. All of that to the 6th power. So here's the easiest thing to do when you're simplifying using your calculator. Do 2 to the 6th times 3 to the 0. And tell me what that is.
64.
Okay, 64 x to the 6th, right? Don't forget we still have to take into account that 6 to the x to the 6th. Now, everybody put you a line right in front of those and put a multiplication symbol behind it. Now we're going to put a plus and we're going to put a line and a multiplication symbol. Now do 2 to the 5th times 3 to the 1. And tell me what that is. 96, what will my variable be? X to the 5th. Put a plus, put a line, and a multiplication symbol. Do 2 to the 4th times 3 to the 2nd. What does that turn out to be? 144. Okay. And that will be x to the 4th. You can see you can't get in a hurry on this. Now this is 2 to the 3rd times 3 to the 3rd. Okay, thank you. That's x to the 3rd. Plus, draw your line. I'm going to show you what the line's for in a little bit. 2 to the 2nd times 3 to the 4th. Okay. That would be x squared. Okay. 2 to the 1 times 3 to the 5th. That's just x. And then the last one is 2 to the 0 times 3 to the 6th. Okay, now, is that 729x? What happened? Because I have an x right there. It's x to the 0, which reduces to 1. Because if it is 0 times something, then my whole end result would be 0. But this is actually a 1. Okay, so that 2 to the 0, you don't have to put in the calculator. That whole term will technically reduce to 1. Okay, so any questions at this point how I've expanded and simplified just the terms in it? Okay, step 3 is Pascal's number. And I'm going to show you the method for Pascal's number. Now, in Pascal's number, we use what is called combination, NCR. Look on your calculator. You should see it above cosine, I believe. It's right by factorial. On the same button as factorial. You'll hit that button twice. Now, what you have to do is the n is the degree of the binomial. So in our case, what is our n? What was the degree of the original binomial? 6. Okay, so in our case, our original, this one right here, is 6. 6c. Now, r is the number of the term, starting with 0. So you actually have a 0th term. If anything is going to be missed on this besides just careless mistakes and maybe typing in something wrong on the calculator, which does happen, the most common mistake is that people forget that this is the 0th term, but this is how you get 7 terms in this. You start with the 0th term, first, second, third. This is not number 1. And when I tell you, or when you realize the patterns, we're fixing to do this, you're going to realize Pascal's triangle has a pattern. Then if you get something other than this number, you're going to understand. So everybody take your calculator out, and how you do NCR on your calculator is you literally type in the 6, hit the NCR, and it'll come up NCR, and then you put the 0 behind it and press enter. What'd you get? 1. Okay. This one would be 6C. So if that's the 0th term, this would actually be the first term. So do 6C1 right there. Okay. This one would be 6C2. Okay. Okay. This one would be 6C3. Okay, 20. This one would be 6C4. 6C5. And 6C6. Now, take a look at my blue numbers in the blanks. Tell me what you notice. All right, so they end up doing what? Repeating. What can we tell about the first and last number?
Same.
They are 1. They will always be 1. Pascal's triangle always starts and ends at 1. So if you happen to do 6C1 here, because you forgot that that's the 0th term, and you get a 6 here, that needs to be a visual that you have messed up. This is always 1. So the ending number is always 1. What do you notice about the second number? It is the same as the degree. So do you actually have to calculate the first 2 or the last 2 numbers? No. Okay, so you know that this one's 1, that one's 1 always. This one is the degree, so is the next to the last. So the only ones I technically have to do is the next one, and I know that if it's odd, it's going to come here. So I don't have to do this one because it's just backing up. And then if you have an odd number of terms, there will be one that does not repeat in the middle. So depending on, you should be able to, have to do half, less than half or half or one more than half. Now, any questions on finding those? I'll show you a little bit of Pascal's triangle here in a minute too. So the last step, and I'm going to put this in blue also, step 4 is to now just simplify again. And we are multiplying. So take a minute and go through and see where I have the multiplication symbols here. You're multiplying these coefficients, which remember your summer work and how I wanted y'all to learn how to multiply things with exponents. Well, you always multiply the coefficients. So go ahead and do that, and then y'all can tell me what that final expanded binomial would look like. tell me these and talk clearly, because sometimes, I'm putting off getting that hearing aid. Okay, so the first one I know, I can do that one. 64 x to the 6th plus, what would that one be?
576 x to the 5th.
Okay, plus
2160
x to the 4th. Okay, plus
4320
x to the 3rd. Okay, plus
4860
x squared plus
2916
x plus 729. Okay. Any questions? That's expanded. Okay, let me show you Pascal's triangle just real quick. So let's say that you have x plus y to the 0 power. What would that work out to be? 1. Okay. Then you're going to have x plus y to the first power. So these are really the coefficients. These are not the variables. So what would this variable be? And then this would be. The coefficients, not the variables. So then if I had x plus y squared, my first and last are 1. Now if you squared that, you'd have x plus y, so you'd have x squared, the coefficient's 1. You have an xy plus an xy, so you have 2 xy's plus y times y. So what are my coefficients here? 1, then 2, then 1. Okay. So I'm not going to expand the third one. I'm going to show you the coefficients. What's the first one? Add those two. Add those, you get 1. There are Pascal's numbers for a third degree. Pascal's number for 1, what's that going to be? Then, no, add 6. Sorry, that's supposed to be a 4.
Yeah, I was going to say, I might not be able to add, I don't know.
Okay, but does the pattern stay true? The first and last is always, the second and the next to last are always the power. Now, what I do not want you to do is write it out to the 20th one where you're adding up. This is the same thing as the NC0, NC1, NC2. So let's just do one more. X plus y to the 5th, so that would be 1. Of course, that's going to be 5. Then that's 10. Then
I'm getting
and 1. So you can carry it out as far as you want to carry it out, but you can also do the combination. The C got asked me last period, does C have a value? No, it does not. There are 2 types when you're talking about probability. There's something called combination and permutation. And it depends on whether order matters or order does not matter. In combination, order does not matter. So if I had 50 members of the club and I chose 5 and it didn't matter the order that I would choose them, it would be 50C5. That would tell me how many different combinations of people I could have. If it was permutation and I had to have a president and a vice president, a secretary and a treasurer, and I needed 4 people, then I would do 50C4 because the order would matter. Like the first person I picked, the second person I picked, or whatever. So C and P on those have to deal with probability and whether order matters in your selection or order does not. But anyway, So what I'm gonna give you right now is I'm gonna let you try to expand one, not quite as hard as that other one, or not quite as long. And let's see what questions you come up with. Okay. Give me just a minute. Okay, before I put in Pascal's numbers, did those look right? I didn't put in Pascal's numbers yet. Is there one? Two to the third times. No. Two, you're adding. You're adding. It's two to the fourth times 5 0. Okay, so what do we know the first and the last to be? 1. Okay, those don't change anything. What do we know the second and the next to the last to be? 4. Okay, so now here is the part, if you're going to miss anything, this is going to be it. So my N is 4, my C. This is not the 1, 2, third term. It's the second. This is the 0th term. And what ought to clue you in is if you did, this is 4C3, you should have gotten 4. And you won't do 4, 4, 4. Okay, you may not know what that is, but you ought to know it's not 4. Because you already have that. So it will be 2. And so it is 6. Okay. So that is 16x to the 4th plus 160x cubed plus 600x squared plus 1000x plus 625. Okay? So that's the foundations to Pascal's triangle. Turn real quick to me. We're not going to do anything else, but I'm going to show you where we're headed. All right, look on the top of page 131. Like number 10 and number 12 are great examples, and we're going to work these in class tomorrow. But 10 and 12 are great examples of the kinds of questions they'll ask you. So we have to get the foundation of doing Pascal's triangle first, and then we'll be able to answer those questions. So we'll work on some of those tomorrow. Okay?